Alright, so I had completed some exercises. Okay, hash map algorithms, right? So we had done. Now it was how to break it. Okay, so I want to learn how can I break this. Okay, I'm finally going to have. Okay, I'm finally going to have you to do some breaking in this exercise, and I want you to write the worst hash function you can and then use the data to prove that it's really bad. Okay, can use to give you the same. Okay, the goal is to make a hash function that seems normal to an untrained eye, but when actually run, it is a bad. Okay, yeah, okay, before. Alright, now I remember what I had to do. Now I remember what I had to do. Alright. Alright, so I have to change these such that um, they work on the. Okay, oh, see, default. This is not generalized, right? This is not generalized. So I want to generalize this the length hash b. Right. So let's generalize this function. Generalize this function. I think I already have a general function, right? So we would need the key, right? Okay, so we would take the key, any type of data, and we'll point to it using a right. Okay. We'll take the size length. All right. So let's generalize these functions. Okay. 32 t hash map fnv1a hash से चैन लिख देता हूँ. So we'll take const point data, right, and I also want to take the length and feet. Okay, why am I taking the pointer? Okay, this will contain a computed hash at the end. Update if seed is provided, else. But this is bad, I can just use, right. Okay, so we will update the seed. It does not use the seed. It also does not use the seed. Okay, and in the hash maps I have hash map hash const void key and a seed. I'm giving a seed, and okay, so hash map of seed. Okay, so I have this seed. Okay, so I'm initializing the seed. This will be initialized once and then used for the lifetime. Ah, okay. Okay. I initialize the seed. Alright. Okay, I got it. I remember now. I used to initialize the seed with time, though I can just change. I would have to remove. Okay, where is map hash being used? So there are tags. Okay, so can you show me this hash function? Yeah, okay. Give me all the references. Okay, so it gives hash map hash pointed to hash. Okay, so let's find. Okay, hash map create. I'm also using in hash maps create and then find bucket and then creates. Okay, alright. So I would have to make the changes here. Okay, so let's make return the pointer to function for generating hash from a key. Let's take a 32-bit seed, right? Hmm. Let's take a 32-bit seed. Map.seed, and I'm going to update. Okay, let's generalize these functions. So let's get rid of the seed, right? Okay, shouldn't be a pointer, and hash map, I think I would have been calling these functions with, let's go with 0. Okay. Before that, these functions are called, right? Okay, control F, control H. I'm going to replace it with 0. Replace, yeah, replace, find, replace, next, replace, nope, 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 nope. Okay, great. Okay, then I have, alright, so go with this and DJB. Okay, so I'm going to make changes in these functions, right? So hashmap algos. Alright, so first we'll take and create underscore t, a pointer, I'll call it key, equals unsigned int, const unsigned int, I guess, right? Yeah, it, call it Okay, wait. Let me change this. Okay, so right. I want to compare the results as well if I have implemented them correct. This is seed, const void, let's call it key. Give me the key. This okay takes void. Let's keep it at data, and this is the general form, and I want to take size as well. Okay, then alright, then I have constant, then say const void key, right, and len. Okay. Okay, well, first of all, I wish to check. Okay, we're going to seed murmur 3, seed equals 0, and 0 else seed. Okay, murmur 332, and I should also have a function calling this char. Right, char key is bdata. Okay, let's see length and then key length. Okay, so I won't even need to do that. I could just use. Okay, let's keep it this. Right. Okay, so I want to first make sure that everything works as is, right? Okay. So I should let's go hash maps test. Yes. Okay. So, okay. So let's make right. I hope I didn't. Okay, I did break. All right. So it says unsigned 32 type, and this is default hash. Alright. I have okay, it says this does not exist. That's okay. I have a default hash. Okay. Okay, so this is the new default hash. Alright. Okay, so like clean, then make. Okay, this. Alright. Okay. So the function works as it is. I have to make changes. Right. So, well, copy this and we'll say right. So I've called it const void data. Let's call it key. Right. Okay. This is the key. Okay. So I'll call it key. And default hash okay. So I'll create const side t data const okay, the const pointer with a const pointer we cannot make changes to the underlying data. We can just read it, so it is read only. Okay, so I have the length, right, then data, and then the size is given by the length, and what, and we have to we are each character b char a. So I'll go with data of I, and then so I want to compare a set of data for only these two functions. Okay. Alright, test. So you can just okay. So what I want to do is I would also have to change my default hash to mirror a. Okay, so now seed. Okay, so we have a seed, we have the data, b data, right. Okay, so let's see, len, right, default hash. Okay, let's not make the changes here. Okay, let's not make the changes here. Let's test. I'll write a new test. Okay, I'll write a new test. Call it test compare hash. Okay, compare hash and none. Okay, so let's create a b string. I think I have some b strings. Okay, be a static address of a string. So I have this and okay. Alright. Okay. So So we can call the hash to do hash okay, hash 1, right? Hash 1 equals let's call the hash function as fn, okay, and of tests, okay. And then I also want to hash 2 equals hash fnv1a hash gen, okay. Now what I want to provide is address of b data, right, address of b data and test 1, right. Then I want the address of this all. Then I want to provide b length of this test 1, and as well as, okay, we don't care about the hash, so I'll here mu assert hash 1 equals hash 2, else you say this is an error, wrong value of hash, okay, wrong value of hash, and I can say hash 1 is this, and say, and hash 2 is this. We have hash 1, hash 2. Alright, so I want to get rid of all these functions here, and then I have, okay, then I have to return, then I have to call this, so we call mu run test compare hash, okay, let's make it again, okay, mu assert undeclared, mu assert is undeclared, are you sure about that? Haven't I used enough mu asserts? Okay, L value required as unary and operand. B, okay, what does B data returns? I think B data itself, okay. Alright, that is not a problem. I want to go source, then see the hard way, and there should be a pstr lib.c .h b data is b data, okay, so b data of, okay, so it itself returns a char pointer, okay, so that is my bad, I should update it, we don't need the address, we just need the b data, okay, so clear, and then we can make it again, and I have again, we have mu set passed 4 arguments, alright, so mu set can't take so test slash mu assert log error message, okay, okay, so it can only Okay, so it can only return the message. Right, right. Right. Okay, so let's see. All tests passed. Right. Can I just for log info um value of hash1 is hash2 is you. Now I can write hash1 and hash2. Okay, so both hashes produce the same value. Okay, good. That's great. That is great. One down, two to go, three more to go. And I feel like I have to go. Alright, so okay, this works fine. But I was thinking, what about integers, right? If I provide an integer, then would how would that work, right? Okay, let's see if I provide integers, right? Okay, so let's copy uh, shift, is it shift? Hmm. Bruh. Okay, whatever. You know, I could do that in Notepad plus plus. I don't know why. This is okay. So let's test it. If I give it value, let's say 20, and I also give it a value 20 and length. Huh. This is a 4-bit. How many bytes? So I can say size of 20, right? Right, right. Is it right or is it wrong? Okay. Okay, FNB. But hmm. So we are only concerned. Okay, let me size of 20. I think this will see this as an int, I suppose. How many bytes, right? Okay. So let's separate this one. Let's write a new test. Char okay, let's say this is hash for primitives. Primitives, right? Okay. So I'll go with this. Let me see what value does it pass. Okay. So we have show primitives. So value of to t value of what is value of hash is this hash. Okay. Alright, so go with this, and then I want to run test hash for primitives. Okay, 20 signed. Huh. Okay, so let's it throws an error. Okay, so it won't take right. Okay, so let me cast it to an int pointer. Nope. Okay, still don't work. Size. Okay, I'm curious what does int f say I want size of just say size of 20. I should really write size of int, but I want to see if size of works this way or not. Okay, size of 20 is all tests passed. Okay, size of 24. Okay, so 4 bytes, right? Okay. How so I can cast it to an unsigned 8 point, right? This value, and then if I try, it still gives me an error. Okay, how was I okay? Because okay, I get it. This is so because this is not an integer, this is a immediate value, right? This is a immediate value, so it won't work the same. Okay, so it is an immediate value and it won't work the same. Alright, so how can I work? Okay, this is a constant, right? And constants I cannot, like constant I cannot do anything about constants, right? Okay, so I can't do anything about constants, you say, but when we use a string, yeah, I can right, but I can also pass. Okay, trying to pass int. See, I can do that. Int a equals 20, right? and then I can pass the address and size of a. This will work, right? This will work. This will work because it is an integer in memory. This will work because this is an integer in memory, right? There's the hash. Okay, so it works for integers, just you have to pass an integer. All right, so okay, so it works for integers, but you will have to pass an integer as well. Okay. So we create certain keys. Okay, let me open this guy up too. Right, okay, so these are all specific values. Okay, so mostly I can pass an integer, but I would have to pass it as that. Okay, yeah, it doesn't really make that much of a difference, right? Okay, hash, compare hash, trying to pass int. Okay, however, you can't do this, that is hash function of 20, then size of 20 comma 0, because 20 is a constant and is not stored anywhere in memory, and does not have a memory address. Okay, part of text. As it's a part of text. Okay, but we works on addresses, go through the each byte, right? Okay, and so same works for floats and other. Okay, but you can also pass an integer as a string, right? You can also pass an integer as a string. Okay, however, mostly you can get the work done with a string, right? Mostly you can get the work done with a string. You get the word string, as you can write most of the you can write any primitive value, int, char and float in a string. Okay, so that is okay, so I have created this. Let's now update this mod adler. Okay, alright, first function, first is we paste it here, then we take this, remove this, it takes data, right? So we go const inside int t data is const inside int t of key. Silent a equals 1, b equals 0. Length will be given, and then you can find data of I. Alright. Data of I. Alright. And then just do this. Okay. So compare hashes. Alright. So we have hash map. This is adler32 underscore hash. Alright, so I can go adler32. Then I think this one is DJB. Right, okay. Okay, now we can test each of these. This is DJP. Okay. Okay, we have hash redefinition. Alright, yes, you're right. There are multiple redefinitions which shouldn't be there. Okay, all test passed. Right, great. So these hash functions are creating what they intend to do with a different data, but now I would have, okay, now I'm going to change let's okay, so the default hash takes void pointer a and also takes a size t len. Right, so it will go size t len. Okay, and then we have a default hash. Okay, we are strictly working with, okay, default hash. Then I have murmur hash 3. You know, it is actually, I can key len and seed. So I should do this. Right, okay, so okay, I don't have to change this. People just have to key and seed, and you have to pass in the values. Okay, a default hash should take in key and value and pass in. Okay, so I can simply just go with hashmap algos. This is Remember 332. So I'll go with this is hashmap Remember 332 underscore hash. Remember 3 so 3 underscore 32 hash, and you have to perform these things in the default hash function. Okay, now hashmap memory 332 underscore hash. Right, 332 underscore hash, and you have to provide hash functions like this. So you have to provide a default hash like this, and this time let's test the hash map. Yes, let's make it okay. Hash map 32 expected, two values, have 3. Okay, make hash map 332. So say hash map 332 underscore hash. Right. I see. 332. We have a const void data size len, and this is okay. Let's make okay, so says data undeclared, first using function. Do you mean b data? Alright, so I must have made some a okay, then we have murmur 332 implicit declaration of function, implicit declaration of function. You are correct. Okay, now I think everything should go as expected. Right, okay, great. Okay, so I can delete this.